So Grignard reagents are really useful carbon-based nucleophiles and useful reagents for the formation of carbon-carbon bonds. So here we'll see an addition of Grignard reagents to ketones to give tertiary alcohols. So this reaction, we start with a ketone and we're adding our Grignard reagent, and when that reaction is complete, we quench with an equivalent of acid. The product in this reaction is a tertiary alcohol. You can see there's 3 carbon groups attached to that carbon. As well, we form a magnesium-based salt, which we usually don't draw. The key bonds that are formed and broken in this reaction are we're forming carbon-carbon, and we're forming oxygen-hydrogen. We're breaking a carbon-oxygen pi bond. So this reaction falls under the category of addition reactions, specifically addition reactions to carbonyls. So for this reaction and for all reactions of Grignard reagents, for our purposes, X here represents a halide. It's whatever halide you started with when you made your Grignard reagent. It could be chlorine, bromine, or iodine, as long as it's not fluorine. For our purposes, it's really quite unimportant. There are many ways of showing how the second quench step occurs. The acid, it's very common to write either H plus or H3O plus or water. All of them perform the same purpose. Essentially, as you'll see later when we go through the mechanism, we're just adding a proton to the oxygen at the end to give a neutral alcohol product. So let's look at a couple of examples of this reaction. Really simple example, we'll start with 2-butanone. We're going to add CH3MgBr, and then we're going to quench with acid, example aqueous HCl. So the product of this reaction, you see we've formed a carbon-carbon bond, carbon CH3, and we've also turned our ketone into an alcohol. Along the way, we formed this magnesium salt. Again, you'll almost never see this drawn, but just for completeness, this would be the counter ions of the magnesium that's formed during the course of this reaction. Another example is here. You could see perhaps the Grignard reagent as the material before the arrow. It doesn't matter what's above the arrow, what's in front of the arrow. What matters is the combination of reagents that you have. So in this case, we have our Grignard reagent on the left, we have our ketone, same process occurring here, same pattern. We're forming a carbon-carbon bond, we're breaking the carbon-oxygen pi bond, we're forming a tertiary alcohol as well as an equivalent of our magnesium salt. And again, the acid quenches just as long as you show that there's some source of acid that's going to give you your final alcohol in the end. It's quite unimportant exactly how you show that. Third example is a symmetrical ketone here. We have 3 carbons attached to our Grignard reagent. Note that here it's magnesium bromide, again, unimportant. Followed by an acid quench, we get our tertiary alcohol and our magnesium salt. This last example I put in here as a little bit of a curveball. So you could see an example of a ketone with some type of group such as an alcohol or carboxylic acid. And it's really important to remember that Grignard reagents are very strong bases. So if you have a molecule with a slightly acidic proton such as an alcohol or a carboxylic acid, the Grignard reagent will react with it. And you'll see that in this example, since our starting material is the same as our product, which is almost like nothing has happened. And in fact, nothing really has happened except that one equivalent of Grignard reagent here removed a proton from the OH, which formed an alkoxide, a negatively charged oxygen, followed by addition of acid gave us back our neutral product. And you see that we also formed our protonated Grignard reagent, in this case propane. So be on the lookout for examples like that. It's a very common mistake. Don't forget that Grignard reagents are strong bases and they'll react with acidic protons. So let's look at the mechanism of this reaction. So this reaction actually is fairly straightforward. There's really only 2 steps you need to concern yourself with. We're starting with a ketone, and if you think about this for a second, just remember where the electrons are. When a ketone, we've got a partial negative charge on our oxygen and a partial positive charge on our carbon. Since oxygen's more electronegative than carbon, the dipole is going to be such that the carbon is electrophilic. And when you think about a Grignard reagent, think about the difference in electronegativity between carbon and magnesium. Carbon is more electronegative than magnesium. It's about 2.5 versus 1. So carbon's going to have a partial negative charge. So that carbon is actually nucleophilic in a Grignard reagent. And it's that partial negative charge that's going to interact with a partial positive charge on the Grignard carbon, or the carbonyl carbon, that's going to lead to the formation of this bond here. And you see that we're forming a carbon-carbon bond. That's happening in arrow A. We're forming carbon-carbon, we're breaking carbon-magnesium. Arrow B is showing the breakage of the carbon-oxygen pi bond. So we're now having a negative charge on the oxygen. This is where the reaction stands and sits around until we add an equivalent of acid. We don't want to isolate the alkoxide, we want to isolate the neutral alcohol. So we add an equivalent of acid, let's say H3O plus. Now I just threw in Cl minus as the counter ion here. It's completely unimportant for our purposes. It's simply a spectator ion. And the oxygen will attack the hydrogen. So remember, even though we've got a positive charge on oxygen, the actual electron density, the electrophilic atom here is hydrogen. And we form an oxygen-hydrogen bond. We break it off to form water. And that is how we obtain our alcohol. And we also form our magnesium salt. I just want to point out there's many different ways of showing the second acid step. I've just shown one. I mean, there's a large variety of different ways. As long as you accomplish the end goal of forming OH, so a neutral alcohol, then you will have succeeded in this purpose. Thanks for watching.